Hello everyone, welcome to the Introduction to Data Science course. I'm your instructor, Ms. Laura Low. In Module 1, we will talk about Introduction to Data Science. And in the next two videos, we will introduce briefly about the Python programming. So the first thing, let's talk about the agenda and the learning objective for this course. The learning objective including we will introduce data science fundamentals. We will know how to collect data and to do the data analysis. And also we will using some data scientist toolbox. In this course, we will using many useful Python library. We will see how to demonstrate and visualize our data. And we also will introduce some critical and fundamental statistic concept. So you will understand how to use the number to represent the data. We will perform exploratory data analysis and create the data visualization. So this one is not only we can using different data science tools, but this class we will focus on using the Python library. The data science toolkits from Python we will use to implement the specific algorithm. And in this course, we will using different examples to represent the data science process and demonstrate the project life cycle. And everyone in this course, you will pick up your topic, what data you are interested to analyze. So then you will work on your personal project to see the data science project life cycle. At the end, you will understand in data science how we do the collaboration, reproducibility, etiquette, and integrative in the data science. Let's further talk about the foundation of data science. Data science actually is a multiple discipline field that extracts meaningful and actionable insight from data. On the other hand, in complementary times, the digital progression has caused a proliferation of data, and the data pertain to diverse domain areas are electronically available across a whole spectrum of million sources. The most important thing, we were using the complex and large volume of data available online. They need to be translated into substantive inference and actionable insight for it to be for any value. Data science actually serves the explicit purpose of translating data into knowledge. So most of the time we need to using the data science is for the data, big data. Data scientists utilize numerous techniques from the field of statistics, mathematics, computer science, and machine learning, and artificial intelligence that convert information into knowledge. So that's why in our data science, we are combining many different fields. You have to have the computer science programming background. You need to understand mathematics and statistics. Then we will apply machine learning and AI technology. So the data science umbrella covers both back-end analysis and the front-end interpretation activity. Data science is a multidisciplinary set of skills that are applied to solve complex problems across diverse disciplines. Visualization of data science domain infrastructure. So this picture actually best describes how the data science came from across the multidiscipline field. So we can see we have the computer science knowledge. We have concepts from mathematics and statistics. And not only those knowledge, you also need to have the domain expertise. What will be for different industry knowledge. So then you will have to use the software development, traditional research about the number, and apply the machine learning algorithm. That's have our data science came from. Data science pipeline workflow involves segmenting complex real-life scenario into subparts, analyzing this as separate entitled as well as ascertain of the association between them by the technique available, and then finally providing holistic and synergistic outlook of the scenario. Data scientists also have a role that comes from the responsibility of exploring, visualizing the data, creating the relevant model, and then finally synthesize it into actionable knowledge. Data science is an art that's not only entitled extracting knowledge and investigating discovery-based pattern, but also articulate this knowledge for the audience to comprehend and use it as a meaning of decision making. The data we are processing will be the big data. Data science entitled addressing the complex big data problem. For instance, we watch Netflix all the time. Netflix would like to extract the viewing pattern of its customer in order to provide future specific suggestion. So then those big data is characterized by three attributes: volume, velocity, and variety. We need to have enough volume, and those data need to from various variety. So velocity about the data. Data dialogue is catalyzed by mobile device, social media, medical biomarker information. Fortunately, this can now be analyzed by powerful machine learning and artificial intelligence algorithm with the sphere of the data science. The data structure of big data comprises unstructured, semi-structured, and structured data. Structured data has a defined format. For example, Oracle database file, CSV files, they are structured. Semi-structured data has a discipline pattern which can be parsed by schema. For example, the XML data has an XXLT schema, and they are defined as a semi-structured data. Caustic structured data can be accessed by analyzed with effort, and a good example of this type is the TXT file or the web click string. At the end, unstructured data has no instinct pattern for the instinct PDF or image or video file. They are considered as unstructured. So that's why we can see the data actually combine with all different forms. That's we all need to find a way to process the data. Phases of a data science project. So the first thing is the business understanding. Business understanding is the objective of the project has to be determined. Then we will do the data mining. The data has to be garnered for the project. Then we need to do the exploratory analysis. So the exploratory analysis entails investigation of the pattern present in the data by numeric and visual technique. The comprehensive pattern detected by this technique must be verified to corroborate the underlying phenomenon portrayed by the data. At the end, inferential analysis. The inferential phases help validate whether the pattern observed in the exploratory phase is substantial or has been observed just by chance. This is achieved by simulating random process in order to quantify whether the observed pattern is an indicator of an underlying phenomenon or not. So at the end, data engineer classify and predict the analysis, extraction of the important predictable feature and construct of the new feature. Here is a typical data science life cycle. So you will see here, we will have data science life cycle, including the problem definition, data exploration, and preparation. So we will make the model training and validation. The model will continue to evaluate and deployment. If we see anything wrong, of course, we need to come back to modify our model and continue to train and validate. So step 3 and 4, they may repeat. So then we'll continue to monitoring the performance. So at the end, we will do the fine tuning and the support. During the data science life cycle, the data science toolbox is important. So they are including the statistic technique. You need to understand the parametric and the non-parametric. And a lot of time we were using the open source software, like the R and the Python. So in this course, we were using the Python. A data science toolbox comprises of advanced statistic technique, mathematical algorithm, software programming technique, machine learning algorithm, as well as the artificial intelligence. The data science paradigms involve the usage of numerous techniques to provide insightful knowledge. Open source software is prevalently being used for the data analysis. R and Python are two important ones, which are often used for the data science analysis. They are software tools. The source code can be viewed by any individual, and anyone can incrementally create newer application and package. The data science infrastructure includes statistic, parametric, and non-parametric, inferential technique like ANOVA, multi-regression, logistic regression, as well as machine learning and AI algorithm, such like the KNN classification, naive Bayes, cluster analysis, and neural network. The toolkits including the model evaluation technique like the confusion matrix, real sample technique, as well as validation technique for better classification. There are many real-life applications about the data science. Some significant ones including on-demand Alexa or Siri recommendation system, self-driving car, powerful search engine, interactive and dynamic traffic reporting system, or the customer service like the chatbot. Data science also involved in the ethic issue. Privacy. Data science tasks can infringe of the privacy of individual. So for the specific organization, the data scientist to prevent it from happening. Transparency. Customer should be informed in how the data being used through the workflow of the usage. Human will. The inference of the prediction of the data science algorithm should not be interfered with the human personal will. Bias. the data science algorithm can sometimes